welcome to our deep dive. Today we're going to be tackling something pretty mind-boggling.
Oh.
Metallic hydrogen.
Hmm.
You might remember this from Cocktail Party Chemistry, episode 51.
Yes.
They called it the Holy Grail of high-pressure physics.
Quite a dramatic title.
It is. But, I mean, when you hear what metallic hydrogen is all about, it kind of makes sense.
Okay.
We're talking about a substance that only exists under extreme pressure. Might be a superconductor, could be what Jupiter's core is made of, and maybe even a super powerful rocket fuel.
Oh.
And the kicker.
What's that?
Scientists are still scratching their heads about whether it can even be stable at normal pressures.
Really?
Yeah. So we're going to unpack those 5 intriguing factoids about metallic hydrogen.
Okay.
Hopefully by the end of this, you'll have a much deeper understanding of this mysterious and potentially revolutionary substance.
Sounds good.
Let's start with the most basic and yet mind-blowing fact. Metallic hydrogen exists only under extreme pressure. So we're not talking about the kind of pressure you experience at the bottom of the ocean.
No.
To create metallic hydrogen, you need pressures comparable to those found deep within gas giants like Jupiter.
Exactly.
It's under these immense forces that hydrogen, which is typically a gas, undergoes a fundamental transformation.
Right.
So what exactly is happening to the hydrogen atoms under such pressure?
Well,
Does it just like squash them together until they become a solid?
it's more complex than that.
Okay.
The pressure forces the hydrogen atoms so close together that their electron clouds begin to overlap. And this sharing of electrons is actually what gives metals their characteristic properties,
Right.
like electroconductivity.
Oh?
So essentially, we're forcing hydrogen to behave like a metal.
Okay, that makes sense.
Yeah.
So it's not just about compressing hydrogen into a smaller space.
Right.
It's about altering its fundamental atomic structure.
Precisely. It's a fascinating example of how extreme conditions can alter the very nature of matter.
And that brings us to the next mind-blowing factoid. The superconductor potential.
Yes.
Now, for those who might not be familiar,
Sure.
can you give us a quick breakdown of what superconductivity is
Of course.
and why it's such a big deal?
So, in simple terms,
Yeah.
superconductivity is the ability of a material to conduct electricity with zero resistance.
Zero.
Zero.
Wow.
Imagine a highway with no traffic jams whatsoever.
Okay.
That's what electricity flowing through a superconductor is like.
So efficient.
Incredibly efficient, because no energy is lost as heat.
So theoretically, if we could harness the superconductivity of metallic hydrogen,
Yes.
we could create incredibly efficient power grids in electronics.
Exactly.
Right.
The potential applications are vast,
Yeah.
ranging from revolutionizing energy transmission and storage to enabling powerful new computing technologies.
But before we get carried away with dreams of a superconductor-powered future,
Right.
we have to acknowledge the elephant in the room, or should I say the gas giant in the room.
Okay.
Metallic hydrogen's superconductor potential only works under those extreme pressures we talked about.
Right.
And I don't think we'll be building power grids inside Jupiter anytime soon.
That is the central challenge when it comes to metallic hydrogen.
Yeah.
Its extraordinary properties are intrinsically linked to these extreme conditions, which are incredibly difficult to replicate
Right.
and maintain here on Earth.
So, in a way, it's a bit of a tease, isn't it?
It is, in a way.
Metallic hydrogen dangles this amazing potential in front of us,
Yeah.
but it seems almost impossible to grasp.
It's a scientific puzzle that continues to intrigue and challenge researchers. But let's not forget that the study of metallic hydrogen has already led to significant advancements in our understanding of high-pressure physics and the behavior of matter under extreme conditions.
That's a good point.
Yeah.
Sometimes the pursuit of a scientific mystery can lead to unexpected discoveries along the way. Speaking of mysteries, our next factoid takes us deep into the heart of our solar system, Jupiter's core.
Okay.
What's the connection between metallic hydrogen and this gas giant?
Well, Jupiter's immense gravity
Okay.
creates the perfect environment for metallic hydrogen to form. The pressures deep within Jupiter are so intense that scientists believe a significant portion of its core could be composed of this exotic substance.
So we have this giant ball of metallic hydrogen swirling around in space.
That's the leading hypothesis.
And this might be happening in other gas giants, too.
Potentially, yes.
Wow.
And it actually explains a lot about Jupiter's unique properties,
Right.
particularly its powerful magnetic field.
Oh, yeah.
It's thought that the swirling motions of metallic hydrogen within Jupiter's core act like a gigantic dynamo, generating the planet's enormous magnetic field.
That is mind-blowing.
It is.
So we have this substance that only exists under immense pressure.
Yes.
Potentially acts as a superconductor. And might be the heart of a gas giant. What other surprises does metallic hydrogen have in store for us?
Well, the next factoid might sound like something straight out of science fiction, but it's a serious area of research. Metallic hydrogen as a potential energy source, even a rocket fuel of the future.
Okay, now that sounds like something straight out of a movie.
Tell
me more about this rocket fuel of the future.
Okay.
What makes metallic hydrogen such a powerful energy source?
It all comes down to the immense energy stored within those compressed hydrogen atoms.
Okay.
Remember, we're talking about forcing hydrogen into a completely different state of matter.
Right.
When metallic hydrogen transitions back to its normal gaseous state,
an
incredible amount of energy is released.
So theoretically, if we could control this transition, we could harness that energy for all sorts of applications.
Precisely.
Including powering spacecraft.
Exactly. The energy density of metallic hydrogen is theoretically far greater than any conventional fuel source we currently use. But harnessing that energy safely and efficiently is a major challenge. It's a challenge that pushes the boundaries of physics, chemistry, and engineering. Imagine trying to contain and control a substance that's essentially a tiny piece of Jupiter's core.
Whoa, that's a pretty wild thought. Seems like we're talking about technology that's years, maybe even decades away.
It might be, but the potential rewards are so significant that researchers are determined to explore every avenue. And who knows, maybe we'll find solutions that we haven't even conceived of yet. Remember how scientists initially thought that targeting the TRPV1 receptor would be a great way to treat pain?
Oh, right. And it turned out to cause dangerous hyperthermia instead. It's a good reminder that even promising research can lead to unexpected roadblocks. But sometimes those roadblocks lead to even more fascinating discoveries.
Precisely. Science is full of twists and turns. Speaking of twists, let's dive into the final factoid, which is perhaps the most intriguing of all. Scientists are still baffled by the question of whether metallic hydrogen can exist outside those intense pressures. It's the ultimate physics puzzle.
Okay, so we've created this substance in labs, we've theorized about its existence in gas giants, but we still don't know if it can exist in a stable form here on Earth at normal atmospheric pressure.
That's the crux of the mystery. Some scientists believe that metallic hydrogen might be metastable, meaning that under the right conditions, it could retain its metallic properties even after the pressure is released.
Oh, interesting.
It's like how diamond, a form of carbon, is formed under immense pressure but remains stable at normal pressures.
So we might be able to create a piece of metallic hydrogen, bring it back to Earth, and it wouldn't just fizzle away.
That's the hope. But it's a question that's sparking intense debate and research. Some studies have hinted at the possibility of metastable metallic hydrogen, but conclusive evidence remains elusive.
It sounds like we're talking about a scientific holy grail. Finding a way to stabilize metallic hydrogen at ambient pressure could unlock all those incredible potential applications we've been discussing.
It would be a groundbreaking discovery with far-reaching implications. Imagine a world where room temperature superconductors are commonplace, where energy storage is revolutionized, where space travel becomes more efficient and accessible.
It's almost too mind-boggling to imagine. But even if stabilizing metallic hydrogen remains a challenge, the research itself is incredibly valuable.
Absolutely. It's pushing the boundaries of our understanding of matter and forcing us to develop new technologies and experimental techniques. Who knows what other scientific breakthroughs might emerge from this pursuit?
That's a great point. Often it's the journey, not just the destination, that yields the most fascinating discoveries. But let's indulge in a bit of speculation for a moment. Let's say, hypothetically, that scientists do find a way to stabilize metallic hydrogen at normal pressure. What kind of impact could that have on our world?
Prepare to have your mind blown. Let's start with energy. Imagine a world where energy loss due to resistance is a thing of the past. Power grids could operate at near perfect efficiency. Electric vehicles could travel incredible distances on a single charge, and we could potentially store massive amounts of energy in compact and safe forms.
So we're talking about a potential energy revolution.
Absolutely. It could transform how we generate, transmit, and consume energy, leading to a more sustainable and electrified future.
And what about those other mind-blowing applications, like rocket fuel and new materials?
The possibilities are truly vast. Metallic hydrogen, with its incredible energy density and potential strength, could revolutionize space travel, allowing us to explore the cosmos more efficiently and sustainably. And the creation of new materials with unprecedented properties could transform industries ranging from aerospace to construction to medicine.
It's like opening a door to a whole new technological era.
It is, but it's important to remember that with such transformative potential comes a need for careful consideration and ethical responsibility.
That's a crucial point. As we delve deeper into the mysteries of metallic hydrogen, we must also consider the potential implications of its applications, both positive and negative.
Indeed. The future of metallic hydrogen is filled with both promise and uncertainty. But one thing is certain. It's a substance that has captured the imagination of scientists and the public alike, and its story is just beginning to unfold.
And as this story unfolds, we'll be here to guide you through the twists, turns, and mind-boggling discoveries. But before we get ahead of ourselves, let's bring this back to Earth, or rather, to that cocktail party where someone first mentioned metallic hydrogen.
Ah, yes. Armed with the knowledge we've gained, we're no longer just armed with a factoid. We have a story to tell, a mystery to ponder, and a glimpse into the forefront of scientific exploration.
Exactly. We can explain that metallic hydrogen isn't just a theoretical concept, it's a real substance that's pushing the boundaries of physics, chemistry, and material science.
We can talk about its potential to revolutionize energy, space travel, and even the materials we use in our everyday lives.
And of course, we can leave them with that lingering question. Will scientists unlock the secret to stabilizing metallic hydrogen at normal pressures? It's a question that will keep them thinking long after the party is over.
And hopefully it will spark their curiosity to delve deeper into the fascinating world of science.
And that's exactly what we've tried to do in this deep dive. We've taken those 5 intriguing factoids from Cocktail Party Chemistry,
Right.
episode 51 about metallic hydrogen, and really unpacked them.
Yeah, we explored the extreme conditions required for its formation, delved into the mind-boggling physics behind its potential as a superconductor,
Right.
and even journeyed to the heart of Jupiter to understand its possible role in planetary magnetic fields.
We've also considered the tantalizing potential of metallic hydrogen as an energy source.
Yes.
And the challenges of stabilizing it at normal pressures.
Absolutely. It's been quite a journey, wouldn't you say?
Absolutely. And it's a journey that highlights the power of scientific curiosity and the importance of exploring even the most seemingly outlandish ideas.
Who would have thought that a simple element like hydrogen,
I know.
the most abundant element in the universe, could hold such extraordinary secrets?
It's a reminder that the universe is full of surprises.
Yeah.
And that even the most fundamental building blocks of matter can exhibit extraordinary properties.
Right.
Under the right conditions.
And as our understanding of metallic hydrogen continues to evolve, we can expect even more surprising discoveries and potential applications to emerge.
So what's the key takeaway for our listeners? What's the one thing you hope they'll remember from this deep dive?
Well, I hope they come away with a sense of wonder.
Yeah.
And a renewed appreciation for the power of scientific inquiry.
Yeah.
Metallic hydrogen is a fascinating example of how extreme conditions can alter the very nature of matter, and how the pursuit of scientific mysteries can lead to unexpected breakthroughs.
I completely agree. It's a reminder that science is not just about memorizing facts. It's about exploring the unknown.
Yes.
Challenging assumptions and pushing the boundaries of what we think is possible.
And who knows?
Yeah.
Maybe one day metallic hydrogen will transform from a scientific curiosity into a technology that shapes our world.
That'd be amazing.
But even if that doesn't happen,
Right.
the knowledge we've gained in the pursuit of this elusive substance will undoubtedly lead to other incredible discoveries.
Well said. It's a testament to the interconnectedness of scientific disciplines and the ripple effects of even the most seemingly niche areas of research.
And as we wrap up this deep dive, I'd like to leave our listeners with a thought.
Okay.
The next time you encounter a seemingly random scientific factoid, don't just dismiss it as trivia.
Go.
Take a moment to consider the story behind it.
Yeah.
The years of research and dedication that went into uncovering that piece of knowledge.
Because within that seemingly insignificant detail, there might be a whole universe of wonder waiting to be explored.
Exactly, just like with metallic hydrogen.
Right.
A substance born under unimaginable pressures, holding the potential to revolutionize our world.
So stay curious, keep exploring, and never stop asking questions.
Yes.
Because that's how we unlock the secrets of the universe and pave the way for a brighter future.
Well said.
And that's a wrap for our deep dive into the world of metallic hydrogen.
It was fun.
We hope you enjoyed the journey and learned something new along the way.
Until next time.
Until next time, keep exploring.